Hello, fans of GeoGebra. In this lesson, we will take things into the geometric window and we will attack this problem, which I think is a great problem to study using GeoGebra because the solution is really simple when you attack it geometrically, but it looks kind of complicated when you attack it algebraically. So we have a curved beam. It's a semicircle. It's fixed at the left. There's a load P that is vertical at the tip. And that's all we're given, P, R. And what we want is the internal reactions somewhere as a function of P, R, and theta. This is from Professor Bodinas' book, problem 1.8. What I'm going to do is demonstrate some of the things that I did here. You don't have to make this quite as fancy as I did. The key idea is to link the angle theta, which describes the semicircular arc or circumcircular arc, link that theta to the geometry of P. And this is where students typically make a mistake, that the decomposition of the applied load is done incorrectly. And it's either this angle is theta or that angle is theta. So I'll try to demonstrate how I did this. Obviously, I put in a radius. I just made it 10. It doesn't, you could do whatever you want. And I put in a theta. There's nothing magic about the theta. And then the graphics here are just kind of, lovely. There's nothing super necessary about any of that. Okay, so we have our window. Once again, always the starting point for me is just to increase the font size, to turn off the labeling. I'm going to put in a radius. Let's say it's 10. It doesn't matter. There's no units in algebra, in GeoGebra. You know that I am interested in overcoming that by putting in pascals, megapascals, gigapascals, feet, and inches, but we don't need that for this exercise. I will drop a point down at the origin. Points always have a capital letter in GeoGebra. That's a little trick. And then I will put in a circle, and there's a choice here of circle with center and radius. It's the second one. So that's the center of my circle. And the radius will be given in the algebra window. There's one little bug that drives me nuts in this program, and I don't know why you can't fix it. It just kind of showed up. You actually have to close the algebra window at least once and then reopen it in order to get the axes and the grid line paper to appear or disappear. That kind of drives me nuts, but don't worry about that. The next thing I will do is I will turn on the axes and I will find the intersection of the circle with the horizontal axis, because that is where the load is applied. So that's under the point menu. It's the fourth one. Pick one entity, pick the other entity. Obviously there's two intersections. I don't need that. So don't delete it, just hide it. Don't delete things, always hide things. Let's go back and turn off those axes, we won't need it. And then I'm just going to put a couple more points on there, on that circle. Doesn't matter where you put them. And we'll take a free body of that piece here. So now I can hide the circle. There's two ways of hiding it. One is to touch it in the geometry window, right click and hit show object. The other is to actually do that in the algebra window. it's worth noting right now that the algebra window is arranged in the way that the robot wants it arranged. I prefer this, so under this, you click here, you could sort by object type. That it makes much more sense to me. So there's the circle. It's there, it's not there. If I delete the circle, everything that depends on the circle disappears. Now we put in a circumcircular arc, one of my favorite words, circumcircular arc. And if you're ever confused about a command in GeoGebra, just hold your mouse over it and it will say, hey, select 3 points on the arc. Un, deux, trois. Okay, perfect. I made it big and fat and blue. Again, right click it, object properties, big fat blue, but you don't have to do all that. This is just looks. Close that. I'm going to turn the window back on. I'm going to draw a line parallel to that to show you the force. Again, you don't have to do that, but it's super sweet. Parallel lines are under the 4th button here. Parallel to the Y, snap it through there. And then I'm going to draw a vector on this. It doesn't matter how long it is. I'm going to hide that line, hide the axes again, and then I'm going to put on a vector. Of course, vectors are red in nature. Make it super fat. Boom. If that's not fat enough, you could change that. Okay, now the next thing I need is that line, that description of the line. Let me maximize this so you could see things better. I put it in as a segment. Segments should probably not be too heavy, so I like the dash dot. I like it green. That looks nice. Now I need that angle just to demonstrate what's happening. So angle, select 3 points, and now it does depend on the order of which you do that. That's one way of doing it. Let me show you the other way of doing it. This to this to this will give you the other angle. That's not what I want, so back off that. So let's go here to here to here. I'm going to call that theta. So you could do that right in here. Rename. I'm going to call that theta. And under theta, under object properties, once again, under the basic tab, there's a really nice button here. Let me move this over so you could see it a little more. Under the basic tab, you could say, show me the value, show me the name and value, or just the name. Typically, I don't want the name, but in this example, I do, because it just looks so nice. Now, I have 3 things out there. I have shear, normal, and the internal moment. So the shear is perpendicular to the member, and that would be parallel to this radius. I could draw a line through here and then do the same little trick with the V that I did with the P. So let me hide the line, don't delete it. Let me put that vector on here. It should be big and fat. I'm going to rename this vector right now just so it looks nice, and I'll just call that V, big V. I think I forgot to rename this. I'll rename this as P. Now I need the perpendicular line to the V, which is the normal. So here's a nice perpendicular. And the same trick, I could put the N on here. Hide the line, don't delete it. Hide that. You can call this N. And then I did a little circle just for the moment. You don't have to do this, but it just looks nice. I'm going to do circle with center through point, just to kind of figure out where I want it. Maybe right there. Hide the circle. Oops, don't hide the circle. Put a couple of points on there, and then that will be my circumcircular arc. Circumcircular arc. 1, 2, 3. I'm going to hide this, hide that, and I won't hide this last one. I'm going to make it an arrow. There are diamonds in here. Color, of course, it's red style. You can make it like that if you want. I think it's not perfect, but you know, oops. If that happens, just open it up again, graphics. I accidentally closed it. And, you know, it looks pretty nice, right? Object properties, make that red. Okay, so that's good. We can call that M. And now the most important thing. So this is all fluff. This is all fluff and presentation, but you know, looks really good. What I really need is this line being parallel to this, right? And now I probably should have maintained this point because I need to establish a perpendicular line. If that ever happens, ladies and gentlemen, just touch the entity and it'll tell you it's a vector from point C to point F. You could see it right there. Just hold your mouse over the entity. It's saying from C to F. And C is already on the table, so that's got to be F. That's got to be F. And it is. So here we go, perpendicular line to this. Tell me if I'm going too slow, I could speed up. Here's an intersect. Boom, boom. Now let's just hide these lines here. Don't delete. I think I said that already. Oops. Don't know what I did there. Oh, I never did that before. That was my laptop. And then hide. What I was going to do is hide this. Yes. Now, the question is, what is theta? Is this theta or that theta? And if you can't do it in your head, which is a little embarrassing if you can't do it in your head, but these things happen. Well, that's a right angle. That ain't it. Is it this angle? Nope. Is it this angle? Nope. So it must be, I'll just leave that there so you see it. So it must be this to this to this. Oops. This to this to this. Oh, shoot. This to this. Oops. This to this to this. There we go. Okay, and now you see that is, let me turn this back on so you see object properties, name and value. Okay, so now you see that is the angle, and now I could put in vectors if you want. You could say, okay, it's going from here to here, and then from here to here. And ladies and gentlemen, then N is P cos theta, and V is P sine theta. And you could type that in. So I put that in here. N is P, what did I say? Cos, right? And for the symbol, let's do this nicely. Where's theta? I don't see theta. Where? There it is. Okay, theta. Or you could put it up here if you want. You could make it red. And then it's really pretty sweet in that you get this idea of the proof. And then obviously I you could leave these little axes. You could put in radius. The moment is very nice. It's this distance. Let me just show you this moment here since I have it. Perpendicular line from here through here. That moment arm to the cut is the radius minus the radius cos theta. So a quick video to demonstrate the power of doing this neatly, accurately with consistent graphics, and then of course you could go back to the previous videos and you could actually put in numbers for theta and make these equations, and then you could just change theta, of course, right? And everything gets updated. The important things get updated. Some of this is not super important, okay? So I hope you enjoyed that. It's super fun, super exciting.